So check this game. This is a really cool game on Android that uses the accelerometer, where I can move the Arcos like this, the Arcos 5 internet tablet, and it just, ooh, I fell down. So this is actually using a Freescale accelerometer technology inside.
Yes, right. Actually, this is using a Freescale Logi ultra low power digital accelerometer, very ultra small form factor. You see that on that board. This is a 3 by 3 millimeter.
So it's just this little one here.
Yeah, that little one. Yeah, that one.
And that tiny chip.
Yes, right.
Is doing the accelerometer thing.
Yeah, it's doing more than the accelerometer. In that chip, you have the G cell, which is sensing the motion, but as well you have an ASIC, a complete, I would say, like a digital processing unit inside the accelerometer, with a lot of smart functions that are embedded in the accelerometer. For sure that product can detect the acceleration data, but as well there is some embedded smart function in that product that can detect, for example, the static orientation, such as portrait landscape detection. So this is automatically processed internally in the accelerometer, as well as functions such as freefall detection. So this is automatically computed internally, as well as real-time orientation detection, tilt detection, the angles. As well, we have implemented some advanced function for power saving purpose, such as auto wake up or auto sleep function based on the motion detection and interrupt generation to wake up the system or to put the system in a sleep mode.
But this is crazy technology. How does it work? How do you make it work? How is it inside? Can you kind of describe what is inside?
Inside you have two dies. One die is the G cell. So the G cell is really the sensing part, which is detecting the motion. So basically, the G cell is
kind of like
it's kind of mechanical fingers that are moving.
Like thousands of these, or millions of these?
Yeah, thousands of those one in the 3 axis, X, Y, G.
In the 3 axis?
In the 3 axis, yes.
Yeah?
And all those fingers are moving, and they are generating a variation of a capacitance, and we are measuring that capacitance. Very, very low values of capacitance variation we can detect with that.
So it means like tiny move, it will detect?
Yeah, tiny move, tiny capacitance variation, picofarad order of magnitude, and detection through the internal ADC, internal ASIC, detection of that, filtering, internal filtering, low pass, high pass filtering internally, and state machine internally computing some advanced function and delivering that complete information to the main processor of the application.
This kind of technology is kind of new, no? In the phones, it's only been like 2 years, 3 years that it's in the phones and stuff like that. Is it because it's reached a small size and a low cost that it's only now that it's used?
Yeah, I think the adoption in the cell phone market is due to probably to 3 factors. The first one is the power consumption. The power consumption has been dramatically reduced in the recent years, down less than 10 microamps when the accelerometer is operating. The second one is due to the form factor. We have products that are very small, 3 by 3 millimeter, less than 1 millimeter height. And the third one is the price as well. There has been a big decrease in the price curve, and this is a commoditization of that product that can be widely used in the consumer market.
And does it have to be calibrated with the Earth's gravity, or how does it work? How does it know? It just knows where up and down and everything is. It's automatic.
Yeah, it's a good question. Let me just show you on this demo, and you will see exactly the effect on the gravity on the accelerometers. So here you've got in blue the z-axis, and you see the 1G linked with the gravity effect on the accelerometers. So very easily, if I can demonstrate, if I go upside down, you see that the gravity now is minus 1G.
This is wireless.
This one is working. Yeah, this is wireless. This is a reference design called Z-Star 3. You can find all the information on Freescale website.
So
everything is on the web, and this is kind of
like this, it goes upside down.
this zigbee type of connection.
This is really crazy. I mean, I think it's crazy. It's just like, whoa. So in this little tiny chip is just a corner of this. It's not even the whole little thing, right? It's just a corner.
Exactly. This is one we've seen at the beginning. Yeah, this is these ones, the accelerometers. And here you can see still on the screen that we have two different nodes, sensor nodes, working at the same time. And you can, of course, get the information of both with Zigbee up to 16 nodes at the same time, sensor nodes at the same time.
So, you know, the Wii controller, there is something extra than just an accelerometer? Or they also have, what's it called?
Yeah, they've got some additional sensor
Yeah?
to get the most accurate function and information. And this is one of the trends in sensors, what we call sensor fusion. Of course, we are also going in this direction. Is not only using accelerometers, but different type of sensor at the same time. And as you synchronize the information to get the most appropriate information and measurement, let's say, at the same time. And this means we will need also probably sensor and micro together and in this type of fusions. And this is the next step arriving in a few months from now. Thanks for the question. And what I would like to show you also as a last demonstration, so for example, this is free fall detection. And
This is
you
the one.
see, yeah, this is also another well-known application. And with accelerometers, easily we can detect the fall. And not only the fall, but you see also we can calculate the length of the fall, you know, with integrating twice the acceleration, you get the distance. And this way you can also calculate.
Let's try and see when you do it. There,
Yeah.
you throw it.
Free fall detection and then measurement of the distance.
Try 1 meter.
1 meter, let's try again.
There. There. Exactly 1 meter. Oh no, that's 1 meter per second. What is it?
It's the time, time of the fall, depending
Okay.
of...
Cool. Okay. So more information at freescale.com.
Yeah, exactly. And particularly this demo, you can get everything on Freescale website.
Cool.